Once again, welcome back to the Automotive Technologies Virtual Conference. So now hopefully you've heard the keynote address, which was delivered by Sarah Gallian, the Software-Defined Vehicle Program Manager for the Eclipse Foundation, which was followed by a session on hardware security modules. If you missed either, both will be available shortly in an on-demand format. This session revolves around the EV charging chain, which has evolved into something that's fairly complex. Our presenter for this session is Jerry Chang, who is the Product Center General Manager for DFI. Before I ask Jerry to begin, I'd like to thank our sponsors. They are ST Microelectronics, Wind River, DFI, and Wolf SSL. My name is Rich Nass, and I'll be your moderator for this session as well as all the other sessions today. I'm also the Executive Vice President of Open Systems Media. I lead the embedded team for embedded computing design. If you're not familiar with that property, check it out. It has all kinds of stuff for the embedded engineer / developer, both hardware and software. You can find it at embeddedcomputing.com. Let me go through some of the housekeeping items before Jerry starts. Some things you should know. When Jerry is done with his presentation, which will likely take 30 or 40 minutes, we will be taking questions from you out in the audience. We'll answer as many as we have time for. You enter that question into the question box on your console there. If you have a problem with the presentation, like if the audio doesn't sound right or the slides aren't advancing, put that into the question box and one of our tech folks will get back to you with the fix. There's also a tab that says resources. Excuse me. If you click on that tab, you can download a copy of the slides that are being presented today. You'll also see a link to all the other presentations that will be available on demand. And you'll also see Jerry's full bio there. Immediately after this session, we've run right into the next one, which happens to be our second keynote address of the day, which is titled How C-V2X Expands the Capabilities of Cloud-Native Vehicles. And then following that, we will wrap up with a session that's called Empowering Bidirectional EV Charging. And again, if you missed anything, you want to go back and review, send it along to a friend. It will be there for you in an on-demand version after we're done. Okay, that is it from me. Let me bring Jerry out to get us started. All yours, Jerry. Take it away.
Yeah. Hello, everyone. My name is Jerry Zhang, Product Center General Manager of DFI. The topic to be discussed now is how to develop the next generation of AI and IoT with more energy efficient and ESG-friendly technology. I will introduce how to integrate multiple OS environments simultaneously using Intel a single CPU through a workload consolidation technology. And what do you have in backpack? 15 years ago, my backpack would contains a camera, MP3 player, a handheld gaming device, and maybe a GPS navigation device, along with various memory cards, data transfer cables. But in your pocket today, you might only have a smartphone, which contains apps like camera, music, Google Maps, and various online games. If there's a need of new features, you download the new apps and find relevant peripheral I/O device. Smartphone has achieved CPU centralization and neutralization, just enabling different functional apps to share the powerful CPU and GPU. This is achieved through a software-defined architecture using containerization and modularization technology. Next, I will introduce how to achieve the simultaneously execution of multi-OS environments on a single CPU through containerization and virtualization technologies. Left side is the hardware architecture commonly used in current IoT applications, where different systems are continuously integrated to meet various demands. Apart from increasing complexity, it also incurs significant additional connection costs, such as various types of transmission cables, LAN cables, and also LAN switches. But nowadays, it is possible to integrate different OS environments under a single CPU hardware architecture through virtualization technology. Through Intel workload consolidation technology, different application demands and OS environments could be integrated under a single CPU hardware. Different OS can communicate securely through Intel BT-C virtual networking and simplifying the overall hardware architecture and reducing deployment costs. The goal of simultaneously executing different functions across a multiple OS platform on a single hardware can also effectively achieve energy saving objectively. And on the right side is the CPU. Uh, on the left side is the CPU performance content obtained from the NSP MSA base, the lower one for the based on the 5 to 10 watt power consumption, and on the left for the left corner, all CPU scores obtained only from the performance test under Intel Tiger Lake Core i7 CPU virtualized into 4 virtual machines as shown. And you can see the overall watt consumption is 32.2 watt only. In the comparison of performance per watt under the condition of virtualization and a single hardware, single core performance can exceed 5 times at the same wattage, while multi-core performance can be approximately doubled. The application of workload consolidation virtualization technology can help steer industries toward more ESG friendly development directions, enabling environmental, social, and governance principles to be implemented in a more diverse manner. It assists in achieving carbon neutralized goals and can give productions a competitive edge in carbon emissions, further reduction carbon tests, and optimizing costs. So now we talk about a software-defined vehicle. Software-defined vehicle is just redefining how vehicles go to market. And first, we check about the legacy microcontroller architecture. It will be fixed function and distributed and closed. Also, more than 100 ECUs, and also more than a mile, a lot of copper cabling, and also the different legacy buses. So when we just use the design with a modern SDV, the software-defined vehicle architecture, will be open and consolidated, connected, and just much fewer ECUs. And also with a high-speed Ethernet with optical cabling, and the N/N-1 NOS to simplify the whole infrastructure and simplify the design too. So in 2023, BMW unveiled the Vision new class concept car featuring an innovative interior layout. The lower edge of the windshield displays a width of information, providing drivers with essential data through a 3D head-up display and a technology called panoramic vision, and as known as its highly customization features. The car is equipped with a large centralized computing CPU, referred to as the super brain of the CPU of the vehicle. And one part of this system is dedicated to handling driving-related information, while the others manage the ADAS related content. Compared to previous systems, the processing speed has significantly increased, also offering drivers a fast and smooth user experience. So let's take the example maybe by different kind of in the ecosystem. Like we use the virtualization technology, allows the car manufacturers to integrate different in-vehicle infotainment system applications, such as dashboard on the infotainment across different OS platforms on a single CPU hardware. They set up flexibly integrated large language model, we call LLM, as Edge AI, executing it on local CPU, GPU, and storage for human-machine interaction in IoT solution that complement autonomous driving. And also this architecture can simultaneously run Linux OS as the dashboard, and Android as the infotainment system and providing multiple interactive Android entertainment systems for passengers and support large language model interaction and allow concurrent execution of multiple OS and enhance the flexibility of the system integration. And this is the concept of machine-led design and POC of DFI. That this one that integrates retail functionalities into EV charging station machine. Apart from changing it allows EV charging station operators to generate additional revenue through integrated retail application, such as advertising and vending. Through virtualization technology, application from different industries could be integrated across different OS platforms under the same CPU hardware. It is equipped with the Intel Arc A380 entry-level graphic cards and OpenMINO technology, allowing large language model to run in edge AI model and on a local CPU, GPU, and storage, but not from the cloud like ChatGPT. And this enables offline AI customer service for the unmanned and autonomous applications, saving on labor costs and also after service costs. The concept machine simultaneously runs Ubuntu for facial detection AI and Windows 10 for advertising playback and Ubuntu for large language model AI and Android for the biggest panel for vending machine or kiosk usage, executing 5 different purpose, and also for the charging station vendor, they can just deliver the food by the AMR robot. So it's just provide the flexibility and create different revenue for the vendor and maybe the charging station owner. And this is the one of DFI's customers' current design for an AMR. AMR is called autonomous mobile robot. It utilize an ARM CPU as the IPC, for the central unit or for the control, and also along with a SLAM simultaneous localization and mapping motherboard, and is upper side for this block diagram, and a right side is a robot controller to control and collaborate the robot arm for controlling different motors for the robot arm and to execute a different task. And now we plan to change the architecture to use a single CPU to perform three different tasks. And by using virtualization technology, we will integrate the three different operating systems with distinct functionalities on a single hardware platform. This will simplify the overall architecture to achieve cost reduction while improving overall energy efficiency and reducing power consumption. Consequently, battery-powered AMRs will be able to operate for a longer distance. This approach will differentiate the product from competitors and achieve a sustainable design and even in the future, like in European market or American market, people will talk about carbon emission. So your system and your product will have a lower carbon emission, provide a lower carbon tax, then you can provide better competitive and for your product to different kind of market, and you can show the differentiation compared to your competitor too. So we are just ready for a next generation AIoT solution. The device is the first industrial computer manufacturer in the world to join the Ubuntu certification program and has a close cooperative relationship with published Canonical for Ubuntu security update, because everyone talk about IoT, and IoT means Internet of Things, and Internet of Things means you need to connect to Internet. So the cybersecurity will be crucial, and is a risk for the device once you connect to the Internet. And Ubuntu Canonical, they will support Ubuntu security update like Windows doing. So it's very important if a customer use Ubuntu, they need to take care about. You need to have some security update feature in the future. And also, of course, and especially in Europe, next year they will have a cyber resilient act. So you need to make sure your system could support security update. Then you can have the just the better ability to just avoid your system from the hackers. And also DFI developed our own low cost OOB module. It's called an out-of-band module, which could remotely operate and update the BIOS, firmware, and also the operating system. Why we need to do that? Because for IoT or AI applications, you need to update the AI algorithm or AI model frequently. But you could not just send engineer to a site to do the update manually. So it means you need to update by on the air by OTA. So you need to take care about once you need to update firmware, software frequently. You need to make sure the system have the ability to the remote management and make sure we can just wake up system, we can just rescue the system by remote control, not just send an engineer. So that's very important that we need to have this capability. And the third one is DFI is the first IPC manufacturer in the world to cooperate with Intel to verify GFX SRIOV and jointly release a technical white paper. The SRIOV is the optimized for virtualization environment technology. That means once your CPU or your hardware to run virtualization, then the SRIOV could just optimize your performance. Even you can use virtualization to run the AI model. So it's very important your hardware could support SRIOV and just the technology I have mentioned about the workload consolidation to just could minimize and your architecture device and also can decrease the material usage, and that means you can have better carbon emission for in the end. So there's some advantage for this technology. And also with the assistance of Intel, DFI has just carry ECI industrial university cooperation with to work as a technical white paper with Intel. And ECI is Intel technology. It's just like a software-defined technology, and we have different program with ECI, and one of the program is we just use the CPU to replace the EtherK card, and customer could remove the EtherK card and let the central CPU to control the whole system, and just can let the customer cost down by removing the EtherK card. So that's another idea for the software defined. We can just use the same CPU to do different job. And containerization and virtualization technology can provide products with advantage in flexibility and energy efficiency during development. So that means we can let the customer apply different OS on the same or single hardware, and it's the same that the customer can migrate the different hardware with the same OS, and just need to minor customize or the modification to migrate your new system from a current CPU or platform to new generation or the new design of your hardware. So that means the flexibility will let the customer have a lower development cost and the development time, and provide the flexibility to different demand of the market. So that will help customer to have a better advantage to adapt to different kind of market. Okay, it's my presentation and today, and thank you for your listening.
Thank you very much, Jerry. Good job.
Yeah.
We do have a bunch of questions here. Looks like we'll be able to get to all of them. For you guys out in the audience there, now is the time to ask your questions of Jerry. He is our expert. You don't normally get an opportunity for somebody at Jerry's level to ask questions of, so now's the time. Okay, so let me ask the ones we got, and we'll see what happens. You ready, Jerry? You want to get a drink or take a nap or something before we get to the questions?
No, it's just,
all right, here we go.
Yeah.
Are these operating systems pre-installed, or can they be substituted with different operating systems on the hypervisor?
Yes, we can pre-install and substitute with a different OS on the hypervisor, and the customer just need to deal with the app level. So the whole environment, you can just based on the environment, just be ready for different OS. And I just mentioned about maybe your customer will require different OS. So that's based on different OS. You can just apply your app system. Like for example, we have a 70% customer based on Windows in current application without any AI. But for the AI model, by some information that they get, we have a 70% model based on Ubuntu. That means we need to have some connection between the Windows and the Ubuntu. So currently we will have a box with Windows, but we will have another box with Windows and Ubuntu for AI. But now we want to consolidate to one box and running Windows and Ubuntu at the same time. The Windows will for current application like a retail automation, but we have an extra Ubuntu OS running AI and based on the same hardware. So you don't need to find different hardware or different box to run different purpose. Now we just let customer could just have you just run your app and based on Windows, based on Ubuntu for AI, and you can just for your product to adapt to your application. Yeah.
That's great. Okay, let's see. Which primary applications do you expect to most widely adopt software-defined vehicles?
Yeah, so let I mention that if your location like EV charging or you like a vehicle.
So you mean I want to clarify this question because we talk about the software vehicle as the total vehicle. You're saying this question is asking I think, and I'm paraphrasing, within the vehicle, which parts of the vehicle are more likely to be defined by software, right? Is that the way you read it? Okay.
So just like I mentioned in the presentation, like a BMW or some infotainment system, be different purpose, but usually for the like a dashboard, is we just use the like a Linux based or real time OS. But for the infotainment or the entertainment system is use Android or Windows, for example. So like we have a multi-purpose and heterogeneous environment. And like now with BMW finally is heterogeneous. You can have a different purpose in the vehicle. So in this condition or this kind of application, you need to combine different OS or different type of purpose into just one location or the nearby area. We just want the customer to know that you can use the software defined and use the virtualization and you just share the same CPU and neutralize the CPU and centralize CPU to achieve the job. And not like currently, we combine just current vehicle we have now in the market, you can find they have a lot of CPU, a lot of NPU, a lot of ECU, and they need to combine together. So we have a lot of cable, we have a lot of peripheral. Then like BMW doing, they use a super brain, then to different purpose, different environment, different OS, different usage. So that's the what we want to let customer know is the total different concept when you just apply this kind of new technology to adapt to the different purpose. Yeah.
Okay, excellent. Let's see this next one. I'm going to paraphrase this one as well. How can an enterprise benefit by implementing software-defined EV charging?
Yeah, let's mention one purpose like flexibility, and the customer can simplify their infrastructure. And the second one, like I mentioned in presentation, that we can help a customer to have a better power efficiency. So that if you just diversely apply your system or your hardware, usually you will have a much higher power consumption. So if we can let customer know, like electric EV car, the EV coming, you will based on the battery. So once customer will rely on the battery, or they just really concerned about the power consumption, this the software-defined or this neutralized CPU technology will help the whole solution have much lower power consumption, and will help the customer, the product could have a better power efficiency, and then that's the benefit. Means you can focus on your different features, but with reasonable power consumption, and you just focus on the good feature, not just need to take care about the power consumption. And this will help the customer have a better solution and for different kind of requirement and demand from market.
Very good. Jerry, that's the questions we got. And it sounds like you did a bang up job here, because you answered all the questions people had a chance to ask them.
Yeah.
Okay. Well, I'd certainly like to thank our expert, Jerry Chang of DFI, for a great presentation and for answering these questions. And again, I want to thank our sponsors, ST Microelectronics, Wind River, DFI, and Wolf SSL. And of course, we can never do anything without you, the engineer, as well. Okay. That's it for this session. Don't go away, because in 21 minutes, we will be hosting the second keynote of the day. And that comes from Wind River. So please jump over to that one, because it's one not to be missed. Thanks, Jerry. You have a great day.
Thank you. Thank you, too. Okay.